Okay, let's get started. Wow, large class today. Okay. Um, that's okay. That's okay. I know that you guys are all doing your things. It's busy time of the year. Thank you for coming. I appreciate it. It sucks teaching to one person. I think that's happened to me before. So what are we doing today? We are basically doing I'm calling it exploring data access. I don't know how many of you are doing data for your final projects, but if you are, then about now you're probably running into some really dumb data access problems. Like, what the hell is a file? Like, what is this file format? Please help me. Um, yeah, so what I'm going to do is give you a really stupid file format that I had to wrestle with when I first started my first research job. Um, and my boss was so nice and helped me to learn how to access this file format. But I would like to give you guys some of the tools to figure out how to access it by yourself. So there is a B courses folder called FITS. And then the PDF that I'm displaying up here is a basically your instructions. The first instruction is to download the file and try to open it without Python and see what you get. Um, it and then once we get through that, I'm going to have you kind of like talk about what it what you see kind of means. Because so far you guys have worked with .csv files, which if you open those, they just open up. And you can look at them. So they're very easy to parse through and kind of get an idea of. By the end of this, we will plot what's in this FITS file. This is a stellar spectrum. So this is a real star that the Dark Energy Spectroscopic Instrument imaged. Yeah, I yanked this star. This is the project I used to work on. Um, and now you are going to plot it. So first try opening it without Python and then talk to each other a little bit about what it kind of means. You get like 2 minutes.
I got this stuff.
And then if you get bored with doing that, feel free to try to open it.
Where is this file located?
B courses here, let me show you. So it'll be if you go to B courses. Oh my goodness. So it's under files, discussions, and then fits. And then it's this fits file discussion file. Okay, let's come back together. What happened when you tried to open it without Python? Yeah.
Those 513 pages of something of Word.
What? That's so funny. I didn't know it would do that, actually. Okay, and then I saw your hand too, Olivia. Oh, bad. Yeah, that's true. It is bad. Do we agree with bad? Yeah, that yeah, no, I also agree with bad. Yeah, if you try to open this file, it's bad. It's really rough. Here's another way to do it. If you just try to, yeah, error. That's an error. I don't like errors. But yeah, so the thing about a FITS file is that it is compressed. When you are taking astronomy data, I don't know why I pronounced it like that, but I did. When you're taking astronomy data, there's a lot of it. Traditional computers cannot handle that amount of data. And so there's a whole lot of different ways that you can work around how much data you're actually getting. And one way is by using compressed file formats that use fancy computer science tricks that I don't know or understand or care about to make the files smaller than they would normally be if they just encrypted or if they just encoded each number as a traditional binary bit. So now that I've had you do that, you're going to use Python to open this. And I'm just kind of going to let you loose on this. It's 3:50. I'll give you 10 minutes to just goof around with this AstroPy documentation. If you just, oh, hi. If you just, open a Google tab and you say how to open a FITS file, that might work. So yeah, go forth, have at it. And you are allowed to talk to each other. Again, how are we doing? Up, middle, down. Okay, that's fair. Fair. Okay, cool. Okay, so we have the file downloaded, yeah? Step one, good. Then we have tried to open it without Python. It's an issue. It's irritating. I don't like it. Have we gotten to peruse the AstroPy documentation a little bit? Okay. Was that helpful? Thumbs up, middle down? It was helpful. Well, middling. Yeah, the AstroPy documentation is really irritating, actually. Oh, come on. Open link. Yeah, it's file handling, and there's just a lot of stuff. But yeah, so does anyone want to start telling me where they started? What did you guys start doing? Yeah.
Dot open.
Okay. On what?
Oh,
So,
actually, before even that, importing it.
import, what am I importing?
Astropy.io, or sorry, from astropy.io, import bits.
From astropy.io import. Oh, oh my God. Okay. Okay, that ran. I like that. I like when things run. Okay. And then what's next?
And then I did some generic file name, so file equals bits.open,
Okay.
and then
What's my file? Bits. Did you guys know that if you hit the tab, it'll autofill? It's really nice because I hate typing shit out. Okay, so let's see what happens. Okay, that also ran. Did anyone else thumbs up, middle down, did we get around to this point? Yeah, okay. What'd you do next? What's next? What did you try next?
I did file.info, ran that, and was very confused in the next 5 minutes.
Okay, did anyone see this? Okay. That's, yeah. So these are all great first steps. Did anyone else get past this thing, or were everyone confused for the next 5 minutes? Up if you got past it. Middle if you're still, I don't know. Down if you are not here yet. And middle if you are stuck here. I'm making this more complicated than it needs to be. Cool, great, love it. Yeah. So, is there anything? Let me think about how to phrase this. What are the confusing things about this? So what's going on? Why is this weird? Why is this strange and funky? Yeah. What makes you say dimensions? That's I can read. I've stared at these so much I forget what the words actually are. Is there something that kind of tells you where the data might actually be though under this dimensions? Because this is a very interesting column to me. Is it interesting to anyone else? And if so, it's interesting, it's not interesting, or whatever. And Charlie, what are you talking about? Yeah, why is it interesting? Thank you. That's very mean. Anyways, yeah. What's interesting about it? Yeah. And then there are two of these HDU things. So type primary HDU. What the hell is a primary HDU? There's a bin table HDU. What is a bin table HDU? I don't know, man. But this dimension tells me that maybe my data is stuck in the bin table HDU because that's kind of what it corresponds to. So you can kind of think about this like a table of contents. So how do we access that second row of things? What's our usual method for accessing something that can be identified with a number next to it? Yeah.
Slicing?
Yeah. I would say indexing, but slicing and indexing, they go hand in hand. So what am I putting inside of the brackets then? I'll give you a hint. It's just one number to get at what we care about. 1? Let's try 1. All right. Okay, that's not helpful. But what this is telling you, is something interesting, and it is that is a bin table HDU object. Maham will talk about object-oriented programming on next week. And you will learn about what objects are. What you need to know is that bin table matches the dimensions of 31,023 rows by 2 columns. So, I don't know. Let me go back to this stupid thing. Yeah, so you guys saw HDUL equals fits.open. HDUL stands for something specific. I forget what it means. Header data unit. This is what I was talking about. They like to compress data down to very low levels of memory. Cool. Yeah, HDUL info that gives you like a table of contents. Blah blah blah. This is not useful. See, they have a whole section called working with large files. Awesome sauce. Okay. So what else is in here? Let's try one more thing. You guys remember what this double question mark means? It's a way of accessing documentation from your Jupyter Notebook. So if you put it after something, for example, a bin table HDU object, so binary table HDU class, it has a specific set of parameters. So it has this parameter called data. It has so many things. That's actually really upsetting, so I'm not going to look at it. So let's try calling data on it. That's funky. But we see numbers. That's interesting. But also, these are really irritating numbers because they're in this thing called the fits rec. What the hell is that? It's a rec array is what it is. And then you have like an array of tuples, which is also weird. Yeah.
Do we do like dot to numpy or something?
Let's see. Okay. Rec array has no attribute to NumPy, but I do like the idea. Have you guys run across as type? And
You go past 5.
oh, lol. I know. What does it do? Really? For .as type? Oh, yeah. So 2 NumPy is something that Pandas has natively. So it wouldn't necessarily give you an error if you didn't have NumPy installed. Because Pandas, the script that holds all the modules, that is Pandas, imports NumPy. So you don't need to have NumPy imported on your Jupyter Notebook in order to work with 2 NumPy that exists in Pandas. But this is very interesting.
Does that mean if we imported pandas, they might work then?
So this is not a pandas data frame. This is a fits file. So this is a bin table HDU. And that's very similar actually to a that is very similar to what's it called? Pandas data frame. It just has more data compression capabilities. So let me all look up fits rec array. Okay, table data, interesting. What's a record array? It's just an array. Okay. Can I numpy.rec array. Each cell is an array of 10 elements. Yeah, okay, so it's just a numpy thing. So let's call this data. And I'm just gonna get rid of the as type. So if I call data, it's just a fits rec array. And now let's try this. And it doesn't like that. Array is one-dimensional. Is it though? Okay, so if I call data 0, 0, then I get a float called 500. If I call 0, 1, then I get a float called 4 point something, whatever. If I open data again, then I see these are also interesting. I have wavelengths and I have fluxes. Wavelengths are in angstroms, which is a weird astro unit. It just is, I think, 100 nanometers or 1,000 nanometers. I should know this. That's okay though. So if I do this, which just means get everything here, or if I do that, it's still going to give me the same thing. I think they changed this on me. But fear not, because there's another option that gets you something much, much, much more like a pandas array. And it is called the table module. So if I say from astropy.table, import table, that ran, I like that. If I call table on not allowed, table on file, length of unsized object, table on data. So table takes a data or takes a bin table HDU object and spits you out something like this. Which I can then now index into with the column names. And then if I call dot data on this table column, so this is a column object, then I can get this array of numbers, which is your wavelengths. So essentially, so I'm gonna say just stick with table. Yes.
Is dot data the same as like dot values?
Yeah. It's exactly the same as dot values. Generally, you can guess that if you're like, is it dot data? Is it dot value? Or if you're trying to get just the numbers out of something with no other fancy schmancy stuff attached, you can probably call either dot data or dot values on it. So play around with this table thing and try to plot wavelength versus flux. So just use this. Use this syntax to plot wavelength versus flux.
The same is not called, so that. Looks I think depending on the same industry.
So table, so you imported table with an uppercase T, and then you called table.
So this is not clear in Hungary.
What's like?
And now there's issue. I think
There-
is that
Oh,
the,
there's one.
so yeah, this is also insensitive. So that's gonna have to be. A and then W also. So this is fine. You will want to get both the data of the label and of the flux with the same settings. And then I'll go over, I'll go through, I'll go over how to do that. So I'll go through all of it. All right, I am going to, with these last 5 minutes, walk you through the rest of this. So, okay, we have this thing called a table that is full of data. I'm going to assign it the name star table because it has a star in it and it is a table. Okay. Our wavelength data is star table. And then we index. Okay, what is it again? I forget. If I call star table, then it's wavelength angstroms. Cool. Wavelength angstroms. Okay, that ran. That's good. That makes me think it worked. And now let's get the flux. And then it's called flux. Okay, that also ran. That makes me think it worked. But these are both column. These are both column objects, not like data we can easily plot. So what we're going to do is dot data on both of those lines. We're going to run them. And then let's do a quick refresher. How do I start my plotting? What's the first line for plotting something? Yeah. PLT dot figure. I kind of want to set the size of the figure. Do you guys remember what the argument is for that?
Take size equal these number by number.
Yeah, let's do like, I don't know, 8,4. It'll be length by height, I believe. Although sometimes I'm wrong. Okay, what's next? What is on the next line? I just want to plot these now. So what's the command? PLT dot what? Yeah, let's put an X label. So what's our X label? Wavelength. Yes. It's always good practice to put the units. If I'm gonna put an X label, I'm gonna put a Y label. And that's gonna be in flux. Ignore what I said about the units. Because these units are really stupid and I don't like them. You can just think about it as like a arbitrary unit. To plot the data though, what's up next? Plot. I love when coders write things that make sense. So we're doing wave because that's on our x-axis, flux because that's on our y-axis. And then I don't like the default color, so I'm gonna put a different color. I really like fire brick. That's a good color. And then I'm going to say plt.grid because I like grids on my plots. And then I'm gonna say, what kind of title should I add? Should I add a title? Yeah, probably. Title. I'm gonna call it a star. That's so descriptive. And then what's my very last line? Yeah. Yeehaw. Shoot. I didn't import it. This is the second time I've done this today, guys. I'm okay. Everything's fine. Import matplot lib.pyplot as plt. Yeah, that was actually a trick. I was testing you and you all failed. Anyways. Whoa, she's pretty. I believe this is I want to say it's an O-type star or an A. The fitter that I worked with that would tell me what these spectra were of sometimes couldn't tell the difference between O, B, and A stars, which was kind of irritating. But also, that's because it wasn't made to fit stars. It was made to fit like quasars and stuff. Cool. It is 4:30. Leave. Have a good day, everyone.
Go get lunch.
It is not lunchtime.